Okay, so let's take some time to understand the concept of the magnitude of a vector. So when you hear the word magnitude, just think length. Okay, so a vector is often represented when you draw it as an arrow that looks like this about. You can point in different directions, whatever, not important. What is important though is the following. Look, if you move this, it's the same length. It doesn't change. It's still say about 5 inches. It's 5 inches here. It's 5 inches here. It's 5 inches here. It's 5 inches everywhere. You see? Doesn't matter where you move it. It's 5 inches. So the length is a constant in this case. Okay, and the way it points is always the same also, right? When you move these things, you see? Doesn't matter where I move it, it's always pointing the same way. Now, one thing that you can do to find the length is just place a ruler alongside and just measure the length, for example, with a ruler. So maybe it's like 5 inches. But if you don't have a ruler, we would like some mathematical way of finding the length of a vector. So how can we do that? Well, you can think about triangles. Now, what kind of triangle do you use? I mean, what if you draw this? Here, look. This is a triangle, correct? So unless you know about the laws of sines and cosines and angles, this is too complicated. So delete this, delete this. You want to use some simpler, the simplest possible maybe triangle that there is, which is a right triangle. So what you do is you draw a perpendicular straight down from here, okay? And then you draw a horizontal leg this way, you see? And this gives you a right triangle because in this position right here, we have a right angle. Now we do know something about right triangles. If we call this A and we call this B, then the length of the hypotenuse, which here would represent the magnitude of the vector, right? They're the same thing. Here you would say that by the Pythagorean theorem, a squared plus b squared is equal to c squared. So this right here, this is c. Okay, so then if you take the square root on both sides, you find the following by taking square roots, that the square root of a squared, like this, right, plus b squared is equal to the square root of c squared. Okay, on the right side, the root and the 2 are inverse operations. You're going to have a squared plus b squared equals c. And that's the length of the vector then. Now you can try this with some numbers. So for example, set this to be 3, set this to be 4. So if you do it in this case, when this is 3 and this is 4, then if you measure with a ruler, right? Let me make this note, right? Measuring with a ruler would give us 5, say, inches if you did this with a ruler for the length of c. Mathematically, look what happens. C, the length, would be equal to the following: the square root of 3 squared plus 4 squared, right? Which is then, look, it's 9 plus 16, which is 25, which is also 5. So in that case, the Pythagorean theorem and a ruler measurement would agree. You can check for yourself. And that's it for this one. So leave a like if it's been helpful and insightful.